Good afternoon, everybody. Hopefully you can everybody hear me okay? Excellent. All right, we won't worry so much about that one. We're going to be passing this, what will seem like a cosmetic microphone to you, but it's for the benefit of the camera. So I'm John Akred. This is Rob Monroe. We'll tell you a little bit more about ourselves in just a second, but we're going to talk about some work we did together with both of our companies for a client of ours, Edmunds.com, which you may be familiar with as a car research and shopping site. As you can verify, that is me. So I'm the CTO of a consulting company based in Mountain View. We're about 50 people, and we work with, we do fun things with data for our clients, typically solving hard problems for which there's no out-of-the-box solution to do it all, often working with fantastic startups who bring new technologies to market to make those problems solvable in the first place. And this is Rob.
On the microphones. So hi everyone, I'm Robert Monroe. I'm the CEO of Edmunds. We're a technology company based here in San Francisco, and we specialize in text analytics into particular dimensions. One is that we work in any language. So we've worked in more than 50 languages to date. And we try to get to state-of-the-art accuracy across a large number of languages. The other side, and this will become particularly relevant here in this talk, is that we specialize in integrating natural language processing with human annotation in order to get to high levels of accuracy as quickly as possible. So we have two members of Edmunds here in the audience as well. So Tripti and Jana, if you can put your hands up and say hi to everyone. We're really interested in hearing about any kind of problems that people are working on in the text analytics space. So we have clients which range from the most visited car website in the world to the United Nations. So we help UNICEF process text messages sent by citizen populations worldwide. So we're always keen to hear more. But today we're talking about the auto industry. Oh, and hello to Elementum.
How's it going? So I'm going to start by talking a little bit about why we did this project in the first place. It's going to sound a little bit like a data strategy interlude, but it also highlights, I think, the opportunity with linguistic assets that can be applied across a range of enterprise use cases, not just the one we're going to talk about today, which is sort of why we ended up choosing this project. But we work with customers to define their roadmaps of technology investments. And when we sat down with Edmunds, their problem wasn't just the one we're going to talk about today. They work in a business that is swimming in a lot of unstructured data. So they are the world's most popular car site. They have folks that provide commentary about those cars and what they like about them and what they don't and things like that. They do full-on editorial articles about cars and reviews and things like that. And then there's the descriptions of the cars themselves as just a few examples of where there's unstructured data in their enterprise. So as we sat down with them to think about what projects we might do to have the most impact on their business, quickly it became obvious that improving their ability to work with text and unstructured data was critical. And the way we sort of arrive at that conclusion is we tend to look across various workloads in an organization. So if you can think of maybe, let's call use case one the browsing for information about cars themselves, research, if you will. And let's call use case two then looking for individual car inventories, going from I'm looking at the BMW 4 Series to, hey, there's this red one with this engine that looks like it's the car meant for me on this dealer's lot. So let's call that use case number two. And maybe use case number three is the customer comments about cars that they accept and allow people to have conversations on their forum, right? Workload B, you'll notice, is common to all of those. And so we would think about the kind of use case we're going to describe as one that we're going to talk about a specific instance, but we can take the assets that we built in the process of doing this, the ontology, the ontological resources, the classifiers, the models that have had the benefit of lots of review and training, and point them at different use cases in the organization. So one of the powerful things about text analytics capabilities when architected well is there's typically a bunch of things in an organization you can point them at. And oftentimes that argument is what gets those things rising in the pile of possible things that a group in an organization might tackle in terms of technology innovation. So we sat down, we thought about what their priorities were, we looked at the dimensions of what they were trying to do in their business and their assumptions. And in this case, that means that they wanted to go to a world of understanding individual car inventory at a very deep level. That right now they had one way of doing that, which was by manually processing the PDFs you'll see shortly that hold the information about cars and what their features and options are. And their assumption was that there was, well, up until we engaged in this conversation, was there were no technical assets that could automate or at least semi-automate and speed that process for them. And so, you know, this is a situation where you've got a combination of a startup who's bringing a product to market that allows you to process text and do the various fun things like entity resolution, concept discovery, et cetera, with it in a way that opens up a problem space to an enterprise like Edmunds over which they have several uses. And so as we go through this, we never think of these things as static. Technology is always changing, right? So simultaneously, the conclusions we came out of the first set of conversations with said, hey, let's go do this stuff. As their business matures, as they come to do other things, the prioritization may change. And actually, one of the interesting things is we've sort of revisited this original conversation with them 3 or 4 times since we started the journey we're about to describe. And it's interesting that the text analytics has stayed right at the top of their priorities and along with some other of the conversation. So I think at a conference like this, I'm probably preaching to the choir, but the fact that you've got an organization who has so many uses for this kind of technology and capability, I think speaks to what's happening in the market around these skills and opportunities as well. So let's talk about Edmunds, the world's most visited site about cars. They actually almost go back this far. They had a Gopher site. Does anybody remember Gopher? Yes, awesome. Precursor to Mosaic, I think from the University of Minnesota, because they're the Gophers. But at any rate, so a very technologically savvy organization that likes to work with startups and explore new technologies. Not all organizations in the world are like this, but we like them because they're very keen to experiment with new capabilities to drive their own competitive advantage. And this is a story of that. So to set up the problem that we had, you know, you see here that they've got a website, and typically people start out by looking at what I will call classes of cars, and I mean that in the object-oriented sense, not like the Mercedes C-Class sense, which occurs to me. I just had a name collision there. But you know, you're looking for, I want a 2-door, I want a coupe, you know, with a sporty engine or something, right? And Mercedes, BMW, all of these places have an answer to that. But if you're looking for one with 4-wheel drive, you know, Mercedes calls that 4MATIC, Audi calls it Quattro, BMW calls it xDrive. Everybody's got their own special term, right? So you can already see sort of some of the linguistic and text analysis challenges that the car industry presents. Rob and I actually met at KDD a couple, 2.5 years ago, I guess at this point, in Chicago, and over beers I was commiserating about this thorny problem, and Rob happened to, unbeknownst to me at the time, have a startup who was focused on car dealer data, or car data at the time. So like all great stories, this idea was born in a bar. So once you go through this research experience of looking at different models and the kind of features and options that are available to you, you typically want to then move to, okay, I think I found my, the twinkle in my eye around this one car. It's funny giving this talk in a city full of people who don't actually drive cars. But down in LA, they sure seem fond of them. There is a world out there where people drive. I occasionally have to drive to the train. They quickly want to find the inventory of the kind of car they've discovered and start to understand it. And it turns out that descriptions of inventory are very, very noisy, and the dealer can do a lot to a car after it arrives on the lot. So they have their dealer added options. And one thing that they want to get right is get a very, very solid description of these actual cars and how they're configured so that you don't go, oh, awesome, the one I've been waiting for all my life is over there. You go to the dealer and it's like, nope, doesn't have that or something, right? So there's a high cost of misclassification is I guess what I'm saying. So they wanted to go from a site that was primarily interested in the class of vehicle, right? A 2015 C-Class to that serial number 1234 2015 C-Class that's black with that engine, air conditioned, dual front zone air conditioning, etc. And the way they get the information that describes that looks like this. Can everyone read that? Just be thankful you never have to. So, so before Rob and I came along, Edmunds had a team of about, I want to say about 40 people, data editors, whose job it was to take, and this is an excerpt of what's probably a few hundred-page document of, it's a German car company, so they, in exquisite detail, describe each and every option and feature and the rules about which ones can co-occur and all that kind of fun stuff, right? Great if you want to sit down at night when you have insomnia and browse a little bit about things you never knew about the 5 series. But if you want to populate a structured database of car features and options to support faceted search across models, kind of a bad format. I describe PDFs as a place where good data goes to die. I'm paraphrasing John Rouser, who once described the enterprise data warehouse thusly, and I also agree with that. But it seems like every 2 years or so, I get a project where the data is hiding in some PDFs, and I optimistically am like, okay, maybe this time someone's got it. And every time, and this is not an insult to the people who are trying to solve this problem. It's admiration of the complexity of what Adobe has created with the PDF spec, I suppose. But it always presents a gigantic problem. And I know some folks around here are engaged in making that problem better, and we wish you all the luck in the world. There's nothing we would like better than to not have to go through what I'm about to describe. But that said, the problem with this world was it would take a human about 3 weeks to basically hand enter this information into a database that backed the faceted search and inventory on their site. And the release of new models is not evenly distributed throughout the year. All the car manufacturers tend to do it, earlier and earlier. But sometime in late summer, you start hearing about the next year's models. And so, on average, that means about 7% of the world of the available cars in any region don't make it up onto their site as inventory. And if you've got a new model that represents an entire class of cars, don't get up on their site until some human goes through this process. Now, if you think about a model where you're advertising supported, so you've got a site that describes a car. BMW releases the 4 Series, which a year or two ago was a new model. And people are curious about that when they read the announcement. And they find out more, and the interest in that drops off over time, you would imagine, right? So if you can actually shift forward in time how quickly they can get to that structured understanding and have that vehicle find it when somebody's searching for a two-door coupe, you're going to make a lot more money on advertising revenue on the one hand. And then like I described, you also want to get all that inventory discoverable, because if they pay some small amount for an ad, a physical lead of an interested car buyer coming from a site who's done this search, found the car, gone to a list and clicked and said, I want to quote on that one, is much, much, much more valuable. It's cents versus $50 or something like that. So, so having 6.5% of all the available inventory in a market undiscoverable is actually leaving a lot of money on the table. And this is also a very siloed operation. So, so this is what we set out to fix. We are working with an existing human process. So one of the reasons we matched so well with an Edmunds solution, as Rob described, is they specialize on a human feedback loop around what the math is doing. And we had, well, as a consultant, this is incredibly refreshing. We worked with a company who wanted to enable a team of humans with technology, not just so they could have fewer of them and fire a bunch. Usually when you're automating or semi-automating someone's job, the goal is actually to automate that workforce out of existence. And I'm happy to say that in this case, it was actually, hey, there's all these other things that those people could be looking for. And there's a lot of value we could extract in our organization if we can empower them and take care of the 80% of the stuff that's easily automatable. So we worked with the folks on the one hand to sort of adjust the way they looked at products, go from a strict engineered system to a probabilistic one, if you will, right? So that rather than having to have the full structured model of a car on the website, you can do some fuzzy matching in those search results and actually change the nature of that time to market problem by making it less, having to have less in place to get it to market. And on the next step, also make it much faster to do that part of that you still have to do. One of our big takeaways is that you have to build this into the process right for it to work well. We fortunately anticipated that, obviously. The whole goal was to empower this team, so we knew we were going to have to work very closely with them to enable them to do their thing. But it's often, I think, an overlooked point when folks are building systems with fancy machine learning and NLP capabilities, that last mile of how you surface that capability to the people who are ultimately going to be using it is really, really important. So this is what we built. A nice, simple picture of boxes and arrows. And I will describe the flow briefly, and then we'll get a bit more deep into the actual technology and how we did it. But to set the stage for that deeper discussion, we pull in those PDFs and we use Scraper Wiki in this case to extract the basic data within that PDF. We had the benefit of having humans involved in this. The extraction did not have to be perfect, and as you may recall from a minute ago, as far as I'm aware, nobody's got a perfect PDF extractor yet. So the editors take that initial extraction, coach it somewhat to make sure that it's reading the documents correctly before importing that extracted information in the form of a CSV into the data environment we use to do the actual work. Once in there, we've basically got a database that has the source vehicle information, and what happens, and we'll show the actual user interface components of this, but there's a data editor who is basically sending descriptive chunks of text, things like dual zone front air conditioning, to the Edmunds service, which is giving back a prediction on what actual ontological element that refers to, or semantic element. So there's lots of ways to describe air conditioning. This is that class of dual zone front air conditioning, the canonical thing, not the description I just used to tell you what it is. And then over time, they set certain thresholds to say, well, if the classification is confident enough, I will accept that. And If not, I will label it and correct it. And so it has a feedback loop. So as we come across things that the classifier gets wrong, we can coach it, and then subsequent predictions will take advantage of that labeling. Interestingly, as we were working on this project, an option showed up, an item showed up that was vacuum cleaner. And we were like, oh, is that a typo? Is there a vacuum cleaner in a car? Turns out Honda put a vacuum cleaner in a minivan. If you have a minivan and put pets or children in it regularly, you probably understand this. I don't have a minivan. I do have dogs. Waiting for them to put vacuum cleaners in smaller models. But turns out that's a classic outlier, right? And so the system is great because when something like that shows up, the editor is able to process it thusly. So this is sort of the existing tool that the Edmunds editors used. It's very cheap and cheerful, sort of Windows, style tree navigation there. You can see that there's 2015. There's some codes there that don't mean a whole lot, but ultimately you can see we're in a series of BMW buckets here, and then these are the individual trim packages. So for them, a class of vehicle is at the trim level, right? So the 528i with X drive, yada, 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 has its own, is distinct from, say, the 535 without four-wheel drive. And what they do is they go and find the model, or if this is a new model, they would create a new bucket, and then they would start importing from CSV, which is what fires up the whole importation process I described. And they get something like this, which, if you think back to that, seems a pretty reasonable representation of a table of features and options that was hard to read. It actually is pulling through symbols in the boxes, and most of these documents have a bizarre language of symbology of what they put in the boxes, which is typically one of those is yes, one of those is maybe, and one of those is no. But this is sort of the first extraction stage. So as long as it's got the columns right, we sort of annotate some stuff up top, tell it where the real data is, then we can start surfacing this information to the capability that Rob's going to describe in a way that allows us to use the prediction service. Shoving a 300-page PDF at Rob's service might have some humorous results, but it's not designed to parse apart a document. It's designed to help you do the kinds of things that we're about to describe. But so the chunking up of the problem is always an interesting part of the whole text analysis process. So you can see they start saying where things are and defining the columns to the extractor, and ultimately wind up with in a world where those entities, which are the columns on the left, have been successfully extracted. And what we're trying to do is guess the three-level hierarchy in the middle, which I'm guessing is hard to read, so I will describe it a little bit. There are the levels of the hierarchy are attribute group, so that's things like stuff about the driver's seat, or stuff about airbags. And within that, we have an attribute name. So if the class is airbags, and you've got, these cars have lots of airbags these days, so one of them might be the head airbag. And then the attribute value might be front or rear. So you're getting to a point where you're saying there's an airbag, it's a head airbag, and it's in the front seat. And that is the level of specificity that these features and options are described, or represented, I should say, in Edmunds' internal database to support the kind of faceted search and discovery. And then over on the right, you can see that in this interface, they basically ask for a prediction, and then when they've got it, they get a confidence interval here that's sort of the combined confidence of that prediction. Rob's going to talk a lot more about how we do this in depth. But we take advantage of the hierarchy that we're trying to predict by sort of stepping through it. So we get a prediction on attribute group when we can narrow it to air conditioning. Obviously, we can, we're essentially narrowing the problem space of the text we're trying to classify now to within the air conditioning category. And in this case, maybe it's air filtration, and then the value is, yeah, there's active charcoal filtering in the air conditioning system, which if you have a puppy like I do, is a good thing. So that's sort of how we framed the problem to the actual NLP capability. Any questions before I?
Is this the actual phrase they present to buyers, car buyers?
This is the phrase in the source document that, for instance, BMW provides to describe the car. So BMW says, we have a feature called microfilter ventilation system with replaceable active charcoal
They
filters.
actually want the buyers to read this. Okay.
Yeah.
So it's not for technical support or repairs.
No.
They want the buyers to read this in German.
That's just one word.
So it's meant to bedazzle the customer. But
Although the interesting thing is it's an internal sourcing document. So if anything, it's meant to bedazzle the buyer at the dealer who's picking how many cars of what varieties they're going to ask for. So it's probably reused marketing materials. If they actually used more sober descriptions of these things, this problem might be easier. But that's sort of what's in that giant PDF in the row, and then it ticks off which option packages include it and things like that, which is a downstream part of the problem that we're trying to solve. So we feed that chunk of text, once we parsed it out of the PDF, into Rob's classifier, which he is now going to describe.
Before we took on this project. So there are 5 kinds of headrests. Like, who can name 2? Right? Like, that counts. No? So you can see the level of specificity there. So I mean, it's not just air conditioning, it's not just filtration, it's a particular type of filtration. So in total, I think that we have the number coming up. So I think it's about 4,000. You could think of them as entities in total, or a classification task. So classifying these short chunks of text into one of 4,000 categories. And as many of you know, 4,000 categories is a lot for an NLP task. Typically, you'd want a large amount of training data, much more than we're actually going to have. So I'll talk about the data sparsity issue and how it fits into the ontology and how it actually turned out not to be a big problem for us. I think it's interesting and fairly unique. But first of all, I want to talk about our fundamental approach. So like John said, we specialize in that feedback loop between humans and machine learning. We certainly weren't trying to replace Edmunds analysts. We're trying to make them more efficient. So we're trying to reduce the 2 to 3 weeks they'll take to get a new car onto their website to have that processed in as short a time as possible. To remove the redundant work from the analysts. So it really is only the novel or the inherently ambiguous items that they have to review. So like I said, it's not just empowering the analyst, it's actually a better approach to more accurate natural language processing as well. So if you saw the keynote yesterday, Mark Lieberman was very happy that almost every single paper at the last ACL was using an existing open data set and comparing themselves to previous results. I actually found that a little bit depressing because this very academic model of keeping the data constant and modifying the algorithm does not necessarily give you the most accurate data. So here's a really good example. So imagine that you're trying to disambiguate the word Ford. In this case, this is data taken from social media across a few languages. So the Ford Mustang would be the correct use of Ford. This is the organization or the car use. But certainly, imagine you're tracking the Ford brand on social media. You don't want Rob Ford's latest gaffe in Toronto to throw off your sentiment analysis. And you don't want Harrison Ford's new movie or Lego character to again, throw off your analysis. So this disambiguation is either something we do directly or is built into a lot of our tasks. Lots of brands, lots of things related to automobile in particular are ambiguous terms or terms that we'll also use in everyday life. So if we apply a linear model with just some fairly standard features like words, n-grams, shapes of features, I think we use dictionaries in this case as well, then we get 0.45 F value. So almost 50% accuracy in distinguishing whether it's for the automobile from whether it is a person use of Ford. So this is just the binary organization versus person usage. I don't think there are any or not very many other sensors of Ford in this data. So if we switch to deep learning algorithms, we get about a 2% gain in accuracy. So a 2% gain in named entity recognition will get you maybe a couple of publications at ACL. Certainly it's enough in itself that it'll get you a PhD. It's not enough that if you go to someone in industry and say, hey, we're 2% better than the competition, that they're going to fall over themselves, unfortunately.
Maybe on Wall Street.
Right, yeah. I mean, yeah, if you're in a hedge fund and you're doing high frequency trades, yeah, there are use cases. So in domain training, so simply taking data which is from the same domain, so data specifically around the auto industry and applying this to this particular task, then you get this huge jump. So you're at about 0.61, 0.62 in F value. But using Edmunds, if we give the right items to our annotators, I'm not going to go into too much detail about what the right items mean, but you can imagine it's a combination of items which are ambiguous, items which promote greater coverage, etc. Just 10 minutes of NLS feedback, and we're automating this task at almost 95% accuracy. So this is just the automated analysis. Obviously, with the humans on top, we're closer to 100. So these are the kinds of gains you get by optimizing humans in the loop in a really, really smart way. So 10 minutes of NLS feedback, versus a PhD. So this speaks very much to our value proposition, as well as to this particular use case. So Edmunds ontology has 4,000 different car features. Their actual ontology is proprietary data, so we're showing you just a small part of it here. And so for this sentence that you saw, microfilter ventilation systems with replaceable active charcoal filters, just rolls off the tongue, right? So this is part of the ontology where it could fit in. So at the top level, air conditioning. The next level, we've got things like filtration, climate control memory, front and rear. And then within filtration, there's a number of categories, and including the one that you saw here. We have about 4,000 features in this ontology in total. So I think it's something like more than 3,500 leaf nodes. And there's only 20,000 we would call labeled items. So existing data points for which the analysts at Edmunds have said, yes, this belongs in this particular category. So this means it's really sparse data, right? So on average, you've only got 5 labels per 5 annotated items per label. But we need to provide a system which requires the input of this expertise, but is also accurate with very few data points. Again, we can't take the academic position of waiting until we've got 10,000 items and then cross-validating on that. We have to be smart about the ways we get to accuracy quickly. So at the top levels, yeah. So at the level of air conditioning, we probably have several hundred items. At the very highest levels, whether it's actually a car feature or not, that's when you've got thousands. So the features we use, words, sequences of words, n-grams, some existing taxonomies, and word shapes. So if you're not familiar with that particular expression, you can think of word shape as a form of industry-specific regular expressions. So you can imagine that a feature might say any number of numbers followed by L. So like a 5-liter engine, a 10-liter engine, etc. And so that allows you to generalize over some of the terminology that might be expressed in very different ways. Negative sampling was interesting as well. So we're mainly getting through positive items. Here are the features, but we're trained in here on a regular classification, supervised classification task. So we need those negative items as well. Oh, I signed a thing saying I wouldn't walk out of camera. Am I walking out of camera right now? What about now? Sorry, Alexi. All right. And so in this case, we would negatively sample items within the same parent. So if we're looking for air filtration, we only have the positive examples there. We know that in this particular case, it's not mutually exclusive because we haven't seen the same item co-labeled with two labels, which they can have. Then we can pull the negative labels from front and rear air conditioning, knowing that by the time the classification has come down from air conditioning, we're only doing the discrimination task within that subcategory. So there's the inherent negative labels for our training items. And then in the complete absence of all data, and this is actually really important from a user point of view, someone types in this new label and they say, hey, I got this new label, interior active charcoal filter. That from a user perspective should be enough, that you can start making reasonable guesses about that, right? So if you have a label in there called interior active charcoal filter, and then you've got this microfilter ventilation system with placed charcoal filters up top, there is actually information there. At that point, before we even have any labeled items which have come back from the Edmunds analysts, we treat the label itself as the data point from which we extract the text. And this was a really minor thing that seems obvious when you talk about it, and haven't seen anyone else do this before. Maybe you've had to do this in tasks in the past, but it was something that kind of overnight really changed the user experience. Not because I was particularly confident with just one data point, no matter how much you oversample, more because it provides some reasonable feedback, even at low accuracy, which felt responsive to the end users. So something I think is really interesting that falls out of this is the accuracy at different depths of the ontology. So cross-validation accuracy, broadly, you expect accuracy to go up with more data items. That's one of our core value props. But when we look at the accuracy, the average accuracy at different depths of the ontology, it actually goes up. So if we're at the first depth, we're right now getting around about 0.8 in F value in terms of accuracy of classifying, say air conditioning versus headrests. The precision is quite high, which in this particular use case is useful for us. If we go to depth 2, so discriminated air filtration from climate control memory or front and rear zones, then the accuracy is actually a little bit higher. It's 0.81, and the precision is again pushing about 0.9. And then if we go to the third depth, this is where we often only have a handful of labeled items. Our accuracy is actually really, really high. It's 0.929. So this is like approaching the level of inter-annotator agreement for a lot of these classes.
So is there a dependency between correctly classifying depth 1 and depth 2?
There is in the ultimate predictions, yeah. So that's something that Edmunds take care of there. So it's not actually in the slides here, but yeah. So they'll start at the top level. Built-in Edmunds system is that can cascade by confidence. Edmunds actually do something a little bit more sophisticated in that they use a combination of confidence at the top level and the cross-validation accuracy at the top level. They use both of those programmatically to optimize what then gets populated further down that ontology for prediction.
So at depth 2, you're considering potentially several classes.
That's right, yeah. So the average branching factor is something around 5, typically, yeah. Yeah, and you can see the precision is quite high here as well. Not shown here as well, though, at this depth, a lot of items will come out at lower confidence. So this is something interesting that we're not trying to tackle right now. The system is working, but it's something to think about. Like, well, if we know that we're actually higher at this level of accuracy, but our confidence isn't up there, simply because we have fewer data items, that lower confidence is mostly the result of smoothing. Are there smart ways that we can sensibly adjust that confidence when we have those smaller number of training items? If anyone from the more technical side has some ideas about that, I'd love to hear about it. I came up in theoretical NLP. I got my PhD in the area at Stanford before I started running a business, so I'm really happy to geek out on the ML side of things. And the reason that we're getting this accuracy, even though it's low confidence, is that it's controlled vocabulary, right? So at the very high levels, you've got things like forward, right? It's inherently ambiguous. It's just a tough task for NLP. Same with air conditioning. So something like aircon, can be abbreviated by things just like AC, right? So AC is an inherently ambiguous acronym that can map to a number of other things. Although I can't think of anything right now. Anyone? AC?
Alternating current.
Alternating current. Oh, right. AC/DC, one of my favorite bands. All right, thank you. Whereas I don't even know if there's an acronym or another way of expressing interior active charcoal filters, but if IACF is something else, it's probably not that widely used. So we get the advantage of at the higher levels, like of saying, well, even if it's even related to cars, where at the lower level, we've kind of gotten rid of that relevance question. And so it really is about the specific parts of the ontology. Anyway, so I thought this was a really interesting insight. It's something that we don't typically see in NLP. So we hand this over to John. So as we mentioned, it was taking 2 to 3 weeks from the world's most visited car site to get information about new cars onto their site when everyone was searching for them. And John's going to tell us how long it's taken them now.
So their backlog is massively reduced, and this is all done via APIs, so that they can extend this to other areas. Like I said, a lot of this is setting it up well to support the existing workflow and processes to realize that benefit. And that requires some coaching of the folks and making that easy for them. So the point I'll leave with is that this asset to how we sort of kick this off from a strategy perspective allows you to use what we've developed by training a bunch of classifiers and NLP capabilities in one task and point that capability at things like comments and do things like entity resolution and concept discovery to understand the different way people refer to these things and ultimately enable sentiment analysis on comments. So what I think is a really nice story, and it's on its own merits of effectively leveraging a very powerful NLP capability to solve a real business problem, is even more goodness when you think about the fact that most organizations have several use cases that they can put these things to. So with that, we'll thank you, and as Rob said, we're happy to geek out on these things after the talk.
We can do one question only, and then we can do the rest also.
Omar, you're first.
So the 2 days turnaround time, what's the percentage of the human in the loop?
What's the percentage of the human in loop? I think not just because it's a famous rule, we're in the neighborhood of 75 to 80% of the features are accurately predicted. I don't know where they've set the threshold within their UI. I should have checked with them before we spoke. But in other words, when we were last talking, somewhere up in the 85 or 90% confidence range is where they would start taking the human out of the loop and just saying, okay, we're going to go with that prediction. They are, on the one hand, continuously training the thing so that their predictions on average over time are going to get more confident. On the other hand, they are getting more confident with that tool and may actually set that threshold slightly lower over time.
Yeah, and even when the humans are in the loop, like John demonstrated, that's a lot more efficient.
Yeah.
So rather than scrolling through to page 30 and typing something out, it's having that immediately presented to them for review.
And they don't seem to miss reclassifying the same boring thing over and over and over again. Thanks, everybody.